Hello, my name is Jonathan Bisnet, and this is the third video in the series on MOSFET transistor circuits. And this one focuses on an OR gate using complementary MOSFETs. Now what you'll actually see in this is, hopefully you've already watched video 2 in the series, the NOR gate, because the really interesting part is when it comes to an OR gate, the only difference is that you take a NOR gate and append an inverter onto the output to create an OR gate. The OR gate's outputs are virtually the inverts of a NOR gate. So the first two sections of this circuit, this one and this one, were really what I showed for the NOR gate. All I did was add an inverter here, which is made up, same thing that I covered in video 1, which is really an N-channel and a P-channel wired in a series configuration with the output taken from between the two of them and run over to the LEDs. So if we look at it here a little bit, what you'll see is that really what I've got is the original first two rows, and then this third row there's an 2N7000 and a TP0610L. The P-channel, the N-channel. This one's, the P-channel's got a positive value going on this red wire going to the source. And the 2N7000, the N-channel, has a negative potential going to its source. The drains are connected together here with this white wire. And then the output is taken off of, in this case, one of the drains. It doesn't really matter since they are connected by this wire. And then the gates, this is the output from the NOR circuit, and then there's an additional wire here to combine the gate to connect both the gates together. So in essence, you've got a NOR circuit with an inverter on the end of it. And to show you kind of what we're looking at here, you'll see that the red LED is on, which is my 0 value, and both of my inputs are not pressed, so they're both zeros. So 0, 0 is giving you a 0 output. If I press one of these, we get a 1, and you'll notice the red LED goes out and the green one lights. If I press the other one, the red goes out and the green one lights. So this is an OR. Either 1, 0 or 0, 1 is going to generate a 1. Also 1, 1, when I hold them both down, you'll see that the green light stays on. If I let go of one of them and then the other one, the green light stays on until they're both off. So basically very simple addition to the circuit. If you watched videos 1 and 2, really all this is a combination of the both of them. And in fact, I'll show you the schematic here so you can kind of see exactly what I'm talking about. So you'll see that just like the NOR gate, you've got the two P-channel MOSFETs in series coming down from the positive rail. You'll see the two N-channel, the two N7000s in parallel, connected basically to the bottom rail or the negative rail. And then the output of that combination of series and parallel is then used as inputs to both the P-channel and N-channel transistors that make up the inverter on the far right of this document. And then finally the output from both of those is run through the LEDs. So really very simple. If you watch the first two videos, none of this should be new or surprising. It's just really a combination of both circuits to accomplish the outputs of an OR gate. I hope you found this one interesting, and watch for more. Thanks.